All right, so this week we're going to talk about paired GANs. As a reminder, here's where we are. So last week we did style transfers. I'm happy to work with anyone who either struggled with it or like just didn't get it last week, and we can talk about it again. I've also been writing up and like slowly writing up recipes that people can just like look at online, and then like you can cut and paste and like put in your own images, and that way hopefully it'll work and it'll be a little bit easier on everybody too. So keep an eye out for that. I'll try to post those in the Slack channel when they're good to go. This week we're going to talk about paired GANs, and then next week we're going to talk about style GAN. So like what's sort of funny is for this week we actually have to talk about style GANs before we talk about paired GANs, because you kind of have to see them combine each other. So I think what this week we'll do, like I'll go through this topic. It'll basically cover like the intuition stuff for the style GAN, and then we'll also go over like the intuition for paired GANs. And then next week, like I'll actually demo like how to do style GAN, but you'll sort of already have an idea. So next week will also be good because like maybe we'll have less of a like teaching class and more of a playing class. So my hope is that like I can get through all the demo in like an hour, and then we'll have like an hour left to like actually talk and maybe start working on things. So the paired GAN stuff, I have like cooking demos, which is like I'll show you half of how to do something, and I'll be like, surprise, I already did the 8 hours of training required, and then we can look at stuff. So hopefully that'll help like speed things along. Don't touch that one. No, I got it. It's all good. Yeah, of course. So like we kind of have to talk about like what is a GAN before we can talk about like what is CycleGAN or what is Pix2Pix. GAN stands for General Adversarial Network. The reason it's called generative is because it makes new things. So there's a whole like actually much larger topic of machine learning that is about like classifying things. Like you send it a dog picture and it says this is a dog. Like that's not generative because it's basically just like it's like classifying things, right? Whereas generative is like producing new images. Adversarial we'll talk about in a second, and then network, which we've already talked about. So the adversarial part is basically this. So these are actually two different machine learning networks. One is called a generator and one is called a discriminator. And you might guess the generator makes things and the discriminator determines what those are. So discriminator is basically like, so here's how this process works. So the generator makes images. So basically like we've seen like this thing where it like produces an image. The discriminator then says like, yes, that's a fake, or like that's a fake image or that's a real image. And then based on this game they play with each other, which is like both of them learn while they're doing this. So basically the generator starts by producing really, really crappy images until it like can fake out the discriminator, and then it learns a little bit more, and then you make the discriminator smarter, and then you like retrain the generator to like get smarter with images. So like that's kind of like confusing to like talk about in like the abstract, but like a really good way to describe that is like, is this a dollar bill? No, it's not a dollar bill, but like at an early stage of like the discriminator, like this might be good enough to fake out the discriminator. So like the generator draws a dollar bill until it gets to this, and then the discriminator says, yes, that's a dollar bill. Then you like make the discriminator a little bit smarter, and then the generator has to like generate more images, and you're like, is this a dollar bill? And like we as humans are like, no, that's definitely not a dollar bill. But to the discriminator, it's like getting a little bit smarter every time, and it's like, yeah, that looks like a dollar bill to me. And then you do it the next time, and like now you're getting closer to like a real dollar bill, and then maybe like what you actually end up at the final stage is this, which like we would still see as fake, but like is smart enough that it looks fairly real to the discriminator. So that's how like GANs work, because they basically just build up and build up, right? So like, and I'll show some examples of this next week, but like with that face demo, like we saw like 3 or 4 years ago, like faces didn't look like real faces. But now they've gotten to the point where they're really good, and that's because these discriminators have gotten smarter and smarter, as well as the way we build them and the generators gotten better and better. So like that's the basic idea of a GAN. Is you've got two models. One is trying to like build a fake thing that fakes out another. Another one's trying to guess whether it's real or not. So the way that paired ImageGANs and CycleGANs work is like sort of the same thing, where it's like it's trying to produce what's on the left here and convert it to the right, and like as it gets better, the thing on the right gets closer to the real thing, right? So this is the example of sort of like what we've seen already, which is like the segment stuff. But there's a bunch of different ways in which you can pair images together to get a network to produce like more realistic things. Or it's also like you can give it a realistic thing, but do something different with it, right? So like in this case, like basically what this has been fed on is probably thousands of images that were color at one point, and then they convert them to black and white. And we try to like, the generator tries to figure out how to convert those two. And the discriminator keeps telling it like, yeah, that's close enough, no, that's fake, that like, it gets better. And then what you can do is you can actually feed it actual black and white images. So some people have like fed like tin types into like, into this process to see what they come out as colorized. Similarly, like you've got like, you can train a whole bunch of winter scenes and a whole bunch of, like if you, in this case, it would actually have to be the actual scene. Like you would, like maybe through like a camera, like what would be like a highway camera. Like you'd actually see scenes in the winter and scenes in the summer, and you would like match them up to each other. And then you could like give it a winter scene that you don't have a summer scene for, and it would produce one. Or I guess it's day and night, so that's probably easier to actually pair. You see a lot with mappings, which is basically like taking Google Street View and then taking an aerial view, and you're gonna like put them next to each other, and then you could like produce essentially fake maps of things that are real. You saw edges to cats. This is edges to purses. Purses seem a lot more boring than cats, but so it goes. And then up here you've got like city scenes. This one is actually like, this was probably really hard to produce. Like they probably got some like research intern to like take thousands of street view images and literally like hand draw them in the shapes and segments until you get this. Now what's also really cool about these systems is like you train it to do A to B, but you could also train it to do B to A. So like you could also, that's where these like segment analysis models come up with, right? Is once you train this, you can also do the reverse, and you can send it a real image and it gives you back segments, or like as best as it can do segments. So some like really cool like tools within this, but like as I'll show you in the demo, this is like the biggest pain in the ass model to work with. Because it has to be like really, really perfectly coupled. And that can be like really, it can be time consuming to produce that, or just really annoying. And then CycleGANs. So CycleGANs are unpaired paired images, which again is like sort of the faces to ramen. Like there's no way to pair those two together, but like if we want to convert those two, like how do we do that? I don't know if anyone's ever done this, but have you ever like done a thing where like in Google Translate you type in a sentence, and then you convert it to like say English to German, and then you convert it back from German to English, and like the words change a little bit. That's basically what CycleGAN does. It converts an image to another image and then back, and sees how like different the image is. That's what the generator does, and the discriminator is then like trying to figure out whether those are fake or real. This is just a good example of like, so Google Translate is based on machine learning, and you'll see there's actually like a problem where previously if you would type in this sentence, so I guess in Turkish there is no gendered, there are no genders assigned to names or whatever. Anyway, it's based on like 100 years of like people translating stuff, and of course like it turns out for the past 100 years we've always assumed doctors have been male. So like when you convert this in Google Translate, it automatically assumes the doctor is a he, whereas is like a non-gendered pronoun, I guess. So when you convert it to English, it automatically like converts it to a men, and it's like people are like, yeah, that's kind of fucked up. So now like Google Translate does a thing where like instead of trying to guess the gender, it just says like, hey, this is a gender neutral pronoun, and like we don't know what it means. So it could mean she or could mean he. But again, it's a place where like when you do machine learning, based on the data set you use, you can get like really messed up, or like both politically and gender incorrect like terms for things.
I wonder what the future has in store. They.
Yeah, definitely. I mean, but that's another thing of like, English has terms for those, but maybe other languages don't, or like don't even care. So yeah, it's. But the thing about CycleGAN then is like, instead of 2 models, there's actually 4 models. So you have 2 generators and 2 discriminators. So you'll find that like CycleGAN like is both slower, but also takes up more memory on your computer. So for a long time, it was like actually hard to do this stuff. But like, I showed you ramen to faces and faces to ramen. The reason it's done this way is literally to show you A to B, B to A. So you'll see that when it comes back, it's fuzzier. And that's sort of, again, that Google Translate thing where it's like, well, we don't really know the exact terms for these things or the exact sentence structure, so it might come back a little bit differently. And here again, you'll see like the faces come back much blurrier. Yeah, so that's how CycleGANs work. So the next thing is like, for all of these, you need a lot of images, right? And I know we talked about this a little bit last week, but I'll just go over it again. So like actually producing these data sets is usually pretty time consuming. So in the case of like that segment thing to Google Street View map, like with the cars and the street scenes, like again, some researcher had to download a bunch of images and like probably hand them off to like the research assistant and be like, cool, color all these in these color codes. And they didn't even know if that would work. So like someone had like spent all that time to do that, and they were guessing if it would actually work. But it did, which is great. But so like finding your own data set, which I know is like some of people have started doing this week, is like kind of annoying. Ways you can find stuff is like you can make your own. It can be very time consuming. Google search, Instagram, Flickr. There's a bunch of code in here, so maybe like when we get past demo, like we can talk about what everyone's making and like go through which of these options is the like best to work with. There's a Flickr scraper, Instagram. I know you said you found a Tumblr scraper. Yeah, so there's a Tumblr one as well. Yeah, so there's probably lots of, basically if you can find a website that has all the images on it you want, you can probably scrape that website and pull in all the images. Or you can do a very manual process and it works, but it's going to take you more time. So I'll talk a little bit about this when we get into demos, but I have a library that helps you sort of like what we would call normalize those images. So Steph, you said you have a bunch of scarves, they're all different shapes, they're all different sizes. Maybe you need to like silhouette some of them. So like this tool won't do the silhouetting, but it will do like the resizing, and it will do like reshaping them. So one of the things that you'll find with paired GANs, the Pix2Pix model, is that it needs everything to be squares. So like almost no images on the internet except for Instagram or Square. So like you have to figure out some ways to manipulate that. So I have some tools, and I'm gonna again write some recipes for this so it can help people understand like how to actually convert those things. This is just how it's gonna work. I recommend actually like doing this on your local computer rather than Paperspace, because depending on the number of images and the size of those images, this can take a while. But you don't need that special GPU to do this. So like you can do this locally on your own computer, and then you can save yourself some Paperspace stuff. I can show you how to do that during demos. So again, we talked about this last week. The easiest thing to grab for this data sets are videos. The hardest thing is like making those perfectly paired folders. And then the weirdest is doing CycleGAN. So I'll just quickly jump through these examples, and then I've got some live demos of things that we can do. So again, this is next frame prediction. This was just a video that I found on YouTube, and then I trained it. This is a pretty short training cycle. I've got some other examples of this where I've like trained a little bit longer. So I'm gonna keep doing that. I'm just gonna move that.
Straight up.
Okay, there we go. Yeah, so, and then I'm gonna skip this one. So again, next frame prediction just takes a video. It's pretty simple. Like, I'd actually, the demo I'm gonna show is on a 30-second video clip or like a 20-second video clip, and it works. Like, the results are very funky. But I would generally say like something a little bit longer is gonna be a little bit better. We'll go, yeah, I'll come back to these. This is basically the steps you wanna use. So after class, if you're still working on this, you can like use these slides as examples. But I'll come back to this and sort of walk us through this model. This is obviously horses to zebras. This is CycleGAN. They actually trained it on static images, and I think that like converts to video, but they might also have done some other little things to make it work in video. So like I said, you can also do winter to summer. And what's great with these paired things is that you can also do the reverse. It's like, with CycleGAN, you actually train both at the same time. With Pix2Pix, you have to train a direction and then train the opposite direction. So it's a little bit more work if you want to do back and forth. But with CycleGAN, I think you can just get both out of the box. I keep showing Faces to Ramen because I love it. These are obviously two unpaired groups. And then this is Pix2Pix. And we talked a little bit about how this like segmenter works. This is like the 15-minute long demo, which I don't need to show. But then you've got edges to cats, which is always fun. Really fucked up edges to cats. Yeah. So I'll do a demo after this. Are there any questions about the stuff I've shown so far? Do you have questions about their own projects? Okay. All right. So why don't I do a demo of So I have a really good demo for next frame prediction and a really good demo for CycleGAN, and I can show you how to start Pix2Pix, but it's kind of annoying and I kind of gave up halfway. But I can show you how to do it if that works for everybody.